All right. Hey, Derbycon. Sorry for that last minute pre-presentation. Oh my gosh, nothing's working. I can't get the screen. How many pen testers did it take to screw in a light bulb and that kind of thing? But it's all up and running now, so we can jump in and get started. All right, as you can tell, this talk is about a tool called Gryffindor. Releasing that today. It's a JavaScript-based backdoor remote administration tool / framework. So we'll kind of see why we're doing something like this, kind of where our toolkit exists in red teaming in general, and then go from there. So first, who am I? Obviously very cool. You can tell by the glasses. Done. I used to be in the Air Force, hence the digs. They're Air Force aviators and such. And BHES, so John Strand, saved my life, kind of like a rescue puppy. And now I'm a penetration tester for Black Hills. I do a lot of web applications, a lot of red teaming, those kind of things. Fun stuff. It's out of those things that tools like this, we find the need for them, and while we start developing a lot of those things and try to give back to the community, if we can. I'm also founder of a company called Open Security and an instructor with the SANS Institute, the author of our Sec 460 course, which launched in August. So it's brand new. So far, it's going really well. I wrote that with Tim Medine, who's also around the conference somewhere, so if you run into him, say hi for me. So when it comes to red team operations in general and just penetration testing, offensive operations, there's a big diversity in the top and most secure we see organizations versus kind of everyone else. And it's not this linear scale where the top 10% is just as much better from the next group of 10% as they are from the one below that. It's completely different. So the top 10% of organizations, we're seeing some really good stuff, some absolutely outstanding defenses and protections they're doing, a lot of active defense, where the blue team is really being focused in on, and they're targeting whatever the attacker's doing, the techniques that the attacker is maybe implementing in order to prevent and to stop those. In the case of these organizations, we're starting to come to this realization that our PowerShell toolkit, which has kind of been developed by the community over the past 5 years, is really not quite cutting it anymore. It's getting really weak. We're running into a lot of defenses that are breaking apart our capability to perform and do offensive actions within our toolkit that we got accustomed to over time. So Microsoft's done a really good job here of putting the tools in the hands of organizations to be able to take on that burden and do some defenses of themselves. These tools, though, do a lot of targeting what they know to be bad, which kind of makes sense, right? If you're going to try to stop malicious activity, figure out what malicious activity looks like, and start blocking that. For us as penetration testers, though, in the open source community, that's a little difficult because many of the tools that we use aren't written by us. In fact, I've never done a penetration test where every single tool that I used on that penetration test was written in-house. I've never done that. Do a lot of tests where most of the tools that we use are built into the operating system themselves, so inherent Windows executables, things that are already there, using a lot of the Windows firewall these days. That just works universally, and it's really nice to have that capability there. But when we get a little bit further, we want to do something a bit deeper, like pull plain text credentials out of memory, or start dumping hashes, or move laterally within, say, a tokenized Windows session. Well, we might want to have a toolkit that's optimized for that. It's also helpful from the perspective of being more covert. If we're using built-in tools, we probably don't have the ability to do things like delay timers and beaconing and jitter, where you mix up the rate at which your command and control communication exfiltrates and infiltrates from the environment, egresses and ingresses. These are things we really want to have in our toolkit. And they are things that we get in things like PowerShell Empire or Cobalt Strike. Cobalt Strike's beacon tool implements a lot of these, and it's quite outstanding. But security vendors are very familiar with those tools, and they do a lot of targeting against what those tools specifically do, and that's not necessarily down to the tactic, as in beaconing malware, but often focused in on the tool itself and its implementation. This creates a challenge for us as penetration testers. On the other hand, the other 90% of organizations, we don't really see a lot of that. PowerShell is probably going to be alive and well in many different ways, shapes, and forms for those organizations for a long period of time. This makes it really weird for us as testers, as in 90% of the time, we are on top, absolutely demigods every day. And the other 10%, we feel like we're getting our butts kicked. There's nothing wrong with that per se, but we do have to make sure that when we do work for our customers, the value that we're providing them does not provide them with a false sense of security that's based off of what we are doing and not what intrusion sets in the real world are doing. So it's okay to lose, just not the wrong way. And so look at that, to know that we are taking up this burden properly and actualizing it for our customers, we actually have to be fairly familiar with what's going on in the real world, what intrusion sets are doing, what kind of attacks they're going after, what their goals are, and how they're implementing that. Because if our toolkit, if what we would normally do is not that, and we're unsuccessful, but they're successful, we've caused that false sense of security for the customer, and that's really, really bad. That's dangerous. So to start, we want to think about what they're doing and why. From the perspective of cyber criminal organizations, often it's all about monetization. We see this grow over time as well. Spam is still a big one. Viagra, got to get that Viagra. That's a way to make money, absolutely. So that's still something to consider. Ransomware grew very, very rapidly. It's still around, absolutely, see it every day. But it is beginning to taper off for things like crypto miners as well, because it's a new way to monetize the exploitation that they've gained against an unwary target. Now that last one is a bit different. Cybercrime as a service isn't necessarily a specific way of doing something like spam or ransomware or crypto miners. It's a way for them to monetize those schemes to others. So we see quite a bit of cybercrime as a service, specifically in the case of ransomware, and we see some interesting ones in the case of crypto miners for blogs that do it wittingly instead of providing ad revenue. It's a pretty interesting thing we're seeing today, because that is potentially malicious software that they are using legitimately. Nothing wrong with that, but it does make it harder to find what's wrong, what's actually bad, block and break that apart. Now, this is a talk about JavaScript. You can do all of these things in JavaScript, and our ad in many cases is. Specifically, we started to see this really start to come up and take speed in 2017. Say in 2017, January time period, they were using a decent amount of Windows scripting host-based JavaScript malware in order to execute things. We'll take a look at what that actually looks like, how it works, and how easy it is to perform here in just a second. But what they started out with is they were using this to run something, and that something would download all of the rest of their malware toolkit, all of these executables, EXEs, to then run whatever it was attack-wise they wanted to do. In the case of ransomware, what this means is they would do some kind of phishing attack or get some user to click on something with a .js file, and that .js file would then download the ransomware. It wasn't itself actually the ransomware, it was a Trojan downloader or a malware downloader. Well, these started to grow in complexity over time. This is what's really interesting in the adversary's perspective when it comes to ransomware specifically. I mentioned before that when antivirus is targeting our tools and we're unsuccessful, that doesn't necessarily reflect upon the intrusion sets. However, in the case of ransomware, we want to make money. And the way we make money is we ransom and extort an organization. The more organizations I can extort, the more money I can make, which means I want to do these as much as possible. This gives antivirus the opportunity to develop signatures and countermeasures and host-based protection mechanisms against something like ransomware. This means less money for the bad guy. The way that they stay ahead of this is they continuously iterate upon their toolkit. In most other malicious offensive operations, we see this iteration take place much more slowly because they're very careful about losing their expensive toolkit that they spent hundreds of hours developing for the purpose of weaponizing your environment and making money off of you. But in the case of ransomware, they can't quite do that, so they need to stay ahead of AV. This means that they make a lot more tools. They keep making more and more and more and more. As penetration testers, when it comes to our backdoors, we could also try to do this. We could make a new backdoor. For every pen test that we do, we would bypass antivirus every time, 100% over 100. Our pen tests have also now become 5,000 times more expensive. This is not necessarily something we have the ability to do. It's because our cost model is different than theirs is. Off of one of these ransomware gigs, they can make tens of thousands or hundreds of thousands of dollars simply because the value of the data that they've now managed to extort the victim organization for. In a penetration test, we can't necessarily do that. But we can observe the growth and development of their toolkit over time and try to replicate some of those features. So what you saw next was a move towards JavaScript-centric malware, where fewer of those ransomware tools were pulled down and downloaded into the organization with that malware downloader. This started with most of the ransomware toolkit with the exception of the cryptography portions of whatever it is that they were doing. They'd be infiltrating these as executables, and there would still be an executable written to disk at some point that would do the actual cryptography and then give you the extortation notice. The first standalone JavaScript-only ransomware that we saw was known as Ransom32, and this is written in NWJS. For those who know what NWJS is, the idea with NWJS is applications on all systems, be they Mac OS X, Windows, Linux, using JavaScript, which is something that people know how to make UIs in, GUIs, very quickly and very easily, that can then run cross-platform. That's what the purpose of Node WebKit, NW, is. One that you might be a little more familiar with is called Electron. It's the same idea, a lot of the same modules in there. It's the idea of having something that can then run on the local system. If you're familiar with Electron, you might have seen the very first slide. The Electron logo was there, and so was the React.js one. The tools that we're going to talk about today are written in those same kind of languages, those same frameworks, so that we can do exactly what the adversary is doing, kind of replicate what their modus operandi is here. So with Ransom32, what it would create is an executable payload. It'd be a .exe file. Binaries are a little suspect. You don't necessarily want to email somebody a binary and hope they double-click on it and get pwned. So you might still need some other kind of payload execution mechanism, some way to stage that, but you ended up with a binary here. To be fair, in penetration testing, we're seeing a lot of movement back towards binary payloads because they just work. They work really, really well, often. The reason for that is we don't see a huge amount of application whitelisting in organizations. There was a push towards this, I would say, 8 years ago, and it kind of tapered out once the community shifted to PowerShell-style malware, and you saw a lot less focus and emphasis on binary payloads. So it's definitely still effective, but not necessarily the easiest thing to immediately get in and start wrecking the network, making havoc. Now the next one here is RAA. RAA is JavaScript, but executed via the Windows scripting host and using the Crypto.js module in order to do the cryptography for the development of the extortation scheme. And finally, what we see in malware as well in JavaScript space are cryptocurrency miners. Typically, these are implemented in JavaScript because you just want system resources. The browser's got system resources. You don't have to pwn the browser in order to get it to do things for you. You just have to use it. And so we see a lot of those implemented in JavaScript because JavaScript's a logical language for browsers. And then when you're ransomwared, you see something like that. Let's take a look at what this actually looks like in practice here. So this is just a Windows operating system, normal computer. Oops, that is not what I want to hit. And we've got here on the desktop a little paystub.doc file. What's interesting about Windows scripting host is it's a .js file, but on Windows, by default, the file extension is not displayed. So you look at this bottom one here, it's Gryffindor.js. I've specifically gone into Windows Explorer in order to say view file extensions. Your average user is not going to see the file extensions on these, so they'll perceive the file extension to be whatever I've put in front of that. In the case of this, it's paystub.doc.js. And for unwitting users, this is also a little interesting because they see the scroll icon. That doesn't look like the standard Microsoft Word icon, but then you've got WordPad as well, and you've got other weird file extensions that maybe aren't too used to. They're definitely not looking at the icon and saying, this is evil for sure, just based off that, and certainly not 100% of the cases within your environment. We only need to get it to execute once in order to be in. If you double-click on this, Windows runs it immediately. This here is JavaScript, and all it says is start a WScript shell and run calc.exe. That looks like this. So that's the code. That's it. Just a few lines. In fact, if you wanted to make it simpler, you could even take out the function definition and just run the code directly. Very simple. And this on the right here is what it would normally look like to a user when the file extensions are hidden. Paystub.doc, paystub.docx, paystub.xsls, whatever you want to call it. But the final extension, the .js, is invisible. This makes it a powerful technique to use to gain that initial exploitation, that initial execution. This is why we see it being used by criminal organizations very, very frequently. And a good way to look at these and differentiate them is to compare it to some other way for us to get execution. Phishing is often the way that we'll get something to run on an environment. It's just kind of a go-to that'll work. We like to do a lot of different things at BHS to get this to happen just because phishing gets boring after a while, but for a criminal organization, boring still sells. Boring still makes money. So we see a lot of phishing. And when you phish someone, oftentimes you're going to have some kind of payload, some kind of document that you send in there. This here is my phish of choice because I'm a really bad person. We'll see why here in a second. Particularly around tax season. So normally here on the top, I'll put a logo of the customer. And this is a charitable donations.xslx file. And it says, hey, it's tax season. The company is going to donate to a charity of your choice here, $400. Pick the 3 charities you would like that $400 to be split amongst. This works. The reason this works is because if you don't pick this, suddenly your charity, suddenly the Wounded Warrior Project isn't getting money. So this always works. This works very well. In fact, this works so well that when we do this, without exception, we'll get an email back from some user in the organization that says, why was I not consulted on what charities were going to make this list? Next year, you absolutely must consult us and add these 3 charities. You're a bad person for not talking to us about it. Thanks. I know you ran it. So what you see here is a pop-up, and that pop-up is asking me if I want to update the Excel document. If we click Update here, it's going to give us another pop-up, and this pop-up says, would you like to start the application msexcel.exe? Sure, I want to start MS Excel. We click Yes, and now we have a calc. There's one other step here for a DDE-based Excel document from a click perspective, and that's the protected view. So in this case, this document I wrote myself, and I saved it onto my own disk. So protected view isn't observed because I made it myself. But if I were to email this to someone else, it's in protected view, and there'll be this little Enable Content button here at the top. Now the reason this ruse says, hey, I need you to modify the document and send it back to me, is because they have to click Enable Content in order to modify the document. There's complexity here, and this is important. I need them now to open the document, that's a double click, then I need them to click 3 different things, edit the document, and send it back to me. And in fact, the complexity goes further because I had to have a ruse that would convince them to do this. In the case of something like Windows Scripting Host, where it's just run and done, a lot less of that complexity means a substantially greater click-through rate. Okay, so that sounds bad. Why would Microsoft have done something like that? I mean, why? JavaScript I get. It needs to run in the browser. That's how you make logic in your web applications. That's how you make HTML5, Web 2.0, nice, model view controller web applications and all that jazz. It makes sense. Got it. But on the host operating system, by default, double-click on a .js file, and it runs it? Well, so who here has ever used Mosaics? First browser for anyone? Yeah, a couple folks use Mosaic. Netscape Navigator, anyone? Yeah, some Netscape Navigators in the house. Internet Explorer, your favorite browser forever? No, I got 1 or 2. This is Internet Explorer 3, so I hope it's not that one. So this is actually the genesis of JavaScript. It was made by the Netscape Corporation as part of the initial browser wars. As we all know, the browser wars are ended. There's the one true browser known as Microsoft Edge. It has won and is king forever and ever. But it's not a new thing, these browser wars. Firefox, of course, is now what Netscape Navigator ended up turning into after Internet Explorer and Microsoft did essentially win the browser war at the time. To win this, though, Microsoft tried everything. They didn't make JavaScript. Heck, they didn't even make HTTPS. But they said, implement everywhere. And this is one of the reasons why the Windows Script host and its consumers throughout the fabric of the Windows operating system exist and can run things in the weirdest of places. You can run scripts, JavaScript or Visual Basic, from within WMI. You can run scripts from JavaScript within RunDLL32. You can just double-click on them and Windows Scripting Host will automatically run these scripts. There are so many different weird, random places inside Microsoft where you can run these things. And this is why it's Windows 95 and Internet Explorer 3 and Mosaic. Thank goodness. So let's talk about AnyFires here for a second, because this is actually a really big reason why we push to JavaScript here for the purpose of post-exploitation capability. It's nice that we can send somebody a .js file, they get a double-click on it, and we're in, and that's done, with no need for dynamic document exchange or some weird Excel thing that might get patched out from under us in the future. As an example, ransomware artists were using a lot of dynamic document exchange as well in order to do ransomware attacks. But they were generally using Microsoft Word for this. Microsoft patched DDE out of Word. The way they patched it out of Word is they removed the feature. It's just not there anymore. Nice patch. But they didn't patch it out of other components of the Office suite, things like Excel, things like Outlook, things like OneNote. So it's still there. A lot of folks think that is not because they saw the patch went across. The patch only affects Microsoft Word. When it comes to JavaScript, well, it looks normal when it's going across the network. If you see JavaScript going across the network over port 80 or port 443, the web application ports, that's pretty normal. You might be able to do something if it was, say, VB script. That looks maybe a little weird if that's being uploaded or downloaded within the network. But JavaScript is very ubiquitous, and we absolutely see that all of the time. When it comes to antivirus here, we've got a lot of signature-based detection mechanisms. That's the traditional way to do things. I'm not really going to bash on antivirus. There's some problems that we've got in the community revolving around antivirus, but I'm not going to bash on it as a tool. I'm not going to say antivirus is dead. I think there's some serious problems there. I think we're definitely still in the signature-based detection space, even if marketing tells you otherwise. Signature-based detection has done really well over the past several months. You use Windows Defender the past several months, it is absolutely on the ball. If it knows about something that's bad, the way to get past it is magic. Do wizard dance. And it changes all the time. So for us at Black Hills, we're spending a substantial amount of time these days getting execution of the tools we would traditionally use, like Cobalt Strike, or Meterpreter from Metasploit, or PowerShell Empire. We spend a lot of time just getting those things to run. And if we need to send somebody a phishing message every time one of these things needs to run, well, that's inefficient, that's horrible, we're going to be in a really bad space here. We're also be wasting a lot of the customer's time and dollars if we're doing this all of the time. And this is because antivirus has focused very, very heavily on the tools that we use. This makes sense if you think about it, right? If I'm a vendor and I need to sell my antivirus product to probably not Microsoft.com because Microsoft makes their own, though you'd be surprised. You've got to sell my antivirus solution to General Motors. I want them to buy it. Okay. If GM says, we want to test out how effective this is, what do? They might grab a pen tester and say, hey, come pen test this thing, can you get it to work? If you beat the pen tester, you must be a really good antivirus solution. And this is where we start to get into pretty dangerous space as penetration testers, because if we get beat by AV, is the attacker, the adversary, the real intrusion set, also getting beat by AV? And if we're not iterating our toolkit, the answer is going to be no. And we can't give our customers that false sense of security by that actually happening. So be very careful here about vendor marketing, because a lot of their terminology is just simply incorrect or ludicrously overblown. That doesn't mean that the engineers in those organizations, those antivirus companies, are bad. I've got some really good friends at Symantec. I know a lot of people at Carbon Black. They're doing some wonderful stuff. Black Hills is a love-hate relationship with Cylance. They send Joff Thayer beers every now and then. They're smart guys, and they're doing good work. But the work isn't necessarily affecting the problem that we're experiencing. I'm not saying that they need to not focus on things like Cobalt Strike. If I'm an intrusion set and Cobalt Strike works, I will absolutely use that because I'm not worried about burning my toolkit if I'm using something that's open source or something that I can pay for. If Cobalt Strike doesn't work, though, then I need to do something else. And for us as penetration testers, we have to also be able to take that next step. We need to be able to do something else as well. So behavioral detection, this is one of those big buzzwords. Most of the implementations of behavioral detection are actually signatures of a pattern of behavior. So it's not a signature for one thing, but it's 2 or 3 things linked together and a signature for that. It's still a signature-based detection mechanism that's not really a behavior. But you'll hear it called that all the time. And then anomaly detection is cool. It's also very, very hype-centric. I think anomalous-based detection is going to be a really cool thing that emerges over the next 5 to 20 years. And I think you might have a little bit of growth there as we get more into and more understanding of machine-based learning. We're not there yet. We're not even close to there yet. Most of these anomalous-based solutions are hot air. So if AV beats your pen testers, does that mean you're safe? Hopefully the answer is yes, but security is not mathematically provable, not directly, and things might come out. This is one of the reasons why I often emphasize that onion model of security, where you layer these security controls, and in many cases what you'll do is you'll give your penetration testers a leg up and say, okay, the antivirus defeated you, but what happens if it doesn't? Because we want to know that too. We want to know if you're stopped during the next stage, the next phases as well. So vendors, of course, they're trying not to have that conversation. They want to look good to sell product. They're businesses. This happens. For us as penetration testers, though, we need to be aware of this, and we absolutely need to be able to perform at the same level as attackers who are using custom and homegrown tools. So this is an example of that. This is actually code written by Geoff Thayer with Black Hills to defeat Cylance. So Cylance had a behavioral-based detection mechanism that essentially would trap on Meterpreter when Meterpreter made a call to create thread. This isn't really going after the behavior, the existence, or the what is of Meterpreter, Metasploit's backdoor. This is going after a very specific call. This is very much a signature. Swapping that call to memory mapping and memory mapping the shellcode before invocation bypasses Cylance. I haven't done this quite recently, but talking to Geoff, I'm pretty sure this still works today. And you're bypassing antivirus vendor that way. Of course, this is a dedicated, specific bypass for a specific vendor. If you have to do this for every vendor that you encounter on every test ever, and when you publish this, they send you beer and fix it, that's not something that's generally sustainable. And this has become a bit of a conundrum for us at Black Hills because we really like to give back to the community, contribute to open source, and just about everything that we do. But we've still got that need and that requirement to effectively do what's best for our customers. So we can't lose to antivirus that we know another intrusion set isn't going to lose to. This means considering holding back some of those latest techniques and starting to stockpile. This is a bad idea. This isn't a place that we want the world to be in. But it is something that we have to consider as penetration testers because we absolutely need to be able to affect the proper amount of value that we've been hired to perform when doing testing. So, when it comes to antivirus, they've got one job, and it's to stop the bad stuff from happening. They focus on a problem that isn't necessarily the right problem, but they do have a place in our information security calculus. So these evasion and detection games are detracting, I think, from the overarching security opportunity for many customers. We have to kind of be aware of that, specifically because I'm seeing a lot of folks taking away a false sense of security because the penetration tester failed or they failed at some stage of the compromise. This is already a dangerous problem that you see happen all the time when the pen tester didn't fail, where they say, well, actually, in a real-world situation, it wouldn't have worked out quite that way, or we accidentally gave you a little bit too much access to the system. Well, the attacker who targeted that one user over there via phishing, that user you also gave a little bit too much access to the system, and therefore the system's now compromised as a result of other user permissions, other user controls. A 0 day is not what's necessary to compromise an organization, and really they might just be a waste of your time if you're going after an organization. So this whole false sense of security, it's something that we want to have. We absolutely want to have that sense of security. We want to stick our head in the sand and pretend like things are good. We absolutely want to. That's just visceral. However, if we're going to do right, we absolutely have to break that and make sure that we have a good understanding of where we are security-wise, be it for the better or for the worse. If we're outstanding and we know we're outstanding and we know where our edges lie, where we've got some weaknesses, that's great. If we're not doing so hot, but we know it, that's still better than not doing very well and not knowing anything about it at all. And as penetration testers, we have to make sure that this gets communicated across to our customers and that we don't lead them into this mind problem, this mind trap, where they think they're more secure than they actually are in the real world. So if we want to do something like this, if we want to bypass these protection mechanisms, antivirus is targeting what it knows to be bad. And so if we target what we know to be good, it becomes much more difficult for antivirus to go after you. When it comes to the top 10% of organizations, some of the defenses that we see them put in place that are absolutely outstanding and very good are focused host-based or network-based. Oftentimes there are human involved doing analysis. It might be host-based analytics on what the processes on the systems are doing. For example, if PowerShell.exe is constantly calling out to a random IP address on the internet from one of the hosts inside your environment, is that okay? You might want to talk to your domain administrators. Maybe somebody wrote a PowerShell script that's doing that. It's weird, but maybe it happened. If spoolsv.exe is beaconing out to some random IP address on the internet, that's your print spooler in Windows, that's probably not okay. Probably pwned. This is a great way for defenders to really get in on the host, get in on the weeds, and start to find bad stuff that's happening, looking for what the host processes are doing. Those processes probably have no business doing. On the other side, the network as well is that same opportunity. If you've got a random IP address on the internet that's being called out to every 5 seconds, that's behavior indicative of beaconing malware, where beaconing malware is reaching out to look for taskings every 5 seconds. When it gets them, it executes it on the system, and then it responds with, here's the output of the command that you just ran. So if we're looking for these kind of things, maybe on a frequency domain, Black Hills has put out a tool called Rita, and there's also a commercial version that they've released called AI Hunter that does a lot of these kind of things. The goal of it is to hunt down beaconing-based malware by doing things like analysis against a frequency domain, against a time spectrum on the network to identify these kinds of activities that are indicative of malware. This will work for PowerShell Empire. This will work for Cobalt Strike. This will work for malicious malware that we've never seen before that also beacons in order to do its C2. This is a common way to do C2, and if we're focused on what that tactic is and breaking that apart, we'll be much more effective. But if we're trying to operate and we want to win, win, win every time, we also need to iterate beyond that. For example, this random IP address that's on the internet that we're beaconing to, should we be going there? There's a lot of use of domain fronting these days to make that not appear to be the same IP address that you're actually communicating out to. There's other techniques as well, like social media-based command and control, where is Twitter blocked in your network? Perhaps. Is Reddit blocked in your network? Maybe you got some social media blacklists going on because you're a really secure organization. Is the New York Times blocked on your network? Well, there's this thing on the New York Times, if you go to an article and you scroll to the bottom, you see a lot of Russian messages in the comments. That means that they can type in information, they can hit post, the information is stored there, anybody else can browse to it and see that information and download it as well. This is everything that you need from a C2 perspective for malware communication. Send information, receive information from some joint host, some joint location. So you can see things like GCAT, which is netcat over Gmail. Absolutely outstanding. That's going to get around basically everyone's network-based controls like that. And when it comes to those kind of things, many of these web applications themselves beacon. For example, you browse to Gmail and you get a new email. That email shows up automatically. That's because your browser is beaconing to that web application consistently in order to find the new information and then adjust the web application state so that you can see your new email as it pops in immediately. JavaScript does a lot of this very well and kind of just intrinsically in many cases, things like Meteor that manage the data state of an application directly. And so these web applications can be hard to discern versus malware as well. Another thing you might look at is payload size. For instance, if we're constantly getting our tweets, our tweet feed, that tweet feed is probably going to look different over time because the size of the tweets, the size of the messages, they're different for each one. As we get a new tweet that shows up there, again, the size of that package can be different. So you can also look on your network for beacon packets that are always the same size. That's another great way to find beaconing malware. So if we want to look real, we want to model what is real. And we can actually use many of these things, like Gmail, like Google Docs, like Twitter, in order to accomplish those ends. There's two pieces here, though, right? There's the network, for sure. But there's also the host. And this is where we have a lot of trouble getting around. Because if we want to have something execute, we could try to inject into the memory space of a process that would normally do this, maybe inject into Explorer, Internet Explorer, or Firefox or Chrome. We could try to do something like this. That's probably not where it's executing to begin with, though, which means if you see that communication activity happen before or after, you can see some things there. But if we really want to model what's good, the browser is making network communications. There are processes on the host that are doing processy things. That looks normal. So if we want to have covert communication, beaconing executables on the host looks suspect. That doesn't look normal. If somebody's looking carefully, they can stumble upon that, and you're caught. Internet traffic from iExplorer.exe, on the other hand, that's probably pretty normal. So the solution here is, for our communication, if we could use the browser and JavaScript, logical language for the browser, to do all of that C2 communication, that's nice. That's covert. Then we've got the problem of system execution, though. Because just JavaScript in the browser doesn't mean you can run things on the local system. You need to have some way to tie that in. Well, Windows has this fancy thing that lets you run JavaScript on the local system too. But it's not the JavaScript that's in the browser. So you might want to have something like browser JavaScript and host JavaScript that are running independently of each other. That Windows scripting host is generally executed via C-script. You can execute with a bunch of different things because everything runs on Windows. It just does. But typically you see that as C-script. If you were to run a C-script based backdoor, you might see on the host cscript.exe making network traffic out on your network might flag that as something that looks malicious, something that looks bad. But if you've got C-script running on your system, it doesn't necessarily mean that the system's compromised by itself. For example, if your users, your admins and such, are doing things with Visual Basic, or they've got a startup script that's in Visual Basic, these things are common. We see them all over networks all the time. They're done ad nauseum. We see this with batch scripts as well. Those normally are running things on the host, or maybe they're doing things to other nodes inside the internal network. They're typically not beaconing out to the internet. So as far as that network behavior, you can still look at that and say that's suspect, but just the execution itself isn't necessarily bad. So we could run something on the host, and we could send the information through the browser. But that means we need to have some kind of linkage between the browser and between that thing that's running on the host. There's a lot of ways we could do this. Now, up here is a diagram of the first way that I thought to do this, and it was a bad idea. So I did it once, and I'm like, this is not a good idea. So the idea is you've got the JavaScript running in the browser, you got the JavaScript running on the host, and then when you've got commands that need to be executed, you've got a netSH firewall rule that's just waiting and logging when it gets a packet. So then when you send the JavaScript in the browser a command, it then browses to the local system, hits that netSH firewall rule, and then it establishes a channel with the local system to pass that data back and forth. Complex, easy to break apart, you need to have netSH firewall permissions, not so cool. And so I was chatting with a friend, and he was like, well, you know, there's artifacts the browser puts in the system, right? Like cookies. Your cookies are stored, you've got temporary internet files. In HTML5, we even got the snazzy thing called local storage. Local storage is a data cache where many HTML5 applications will store information. And this information isn't simply temporary for that browser session. It's actually stored on the local system so that if you were to open up that browser and go to that website again, then you still have access to that local storage, that local cache of information. So the web browser and the JavaScript running in it can add things to local storage. That's its purpose. But local storage lives actually on the physical file system. So if you've got something running on the physical file system, it can edit that information as well. And since all of this is in the app data directory of that user, if you're running as that user, you've got the permissions to edit and interact with this information. So you can trade information back and forth here through a local file system I/O channel where your execution on the host makes no network communication whatsoever, but your execution in the browser does all of that. And if you want to run something on the host, the browser tells the JavaScript on the host to run that stuff for you. All right. And so in comes Gryffindor. It's a tool that I wrote to do a lot of these kind of things. There's several ways you can, of course, make JavaScript-based malware. We kind of talked through them, but to summarize, you could use something like Electron or NWJS to create something like an executable to run. The code for that would be almost exactly equivalent to the code that you would use for whatever's running in the browser, because remember, NWJS and Electron are just a website in an executable. They're packaged around the Chromium project, and that's how it achieves those ends. So we can definitely have executables if we want to with JavaScript. We can have JavaScript payloads that are running in the browser. We can establish browser sessions. These are also pretty interesting, because let's say you have no ability to execute on the local system. Does that mean you can't C2 in the network or do things to the internal environment? The answer is no. If you own the browser, and the browser's behind their firewall, their internal firewall, you can have that browser do other things to things behind the internal firewall. You absolutely can. So there is value in these browser sessions. The Beef project is a good example of this, where you've got Beef hooks that you would put into the browser to control the browser long term. You can have the browser do things. Now, Beef's also been around for quite a long time. It hasn't seen a huge amount of development in recent years, but browsers have. Chrome and Firefox and those projects have absolutely exploded the capability of a browser itself. And so now browsers are very nearly an operating system in and of themselves. You've got some difficulties back and forth, as in CORS, which prevents you from getting things that are not from the same domain as you are. So if you're in the browser and you own the browser, that doesn't technically mean you own things from every resource that the browser's ever communicated with. That browser sandboxing does still tie our hands a little bit. But if we own the browser, we've got some kind of session going on inside their environment. And with the growth of a lot of these browser technologies like WebRTC, that means we can do a lot of things. For instance, WebRTC is used to do full torrent clients that stream, like download a torrent thing through browsers. And the peer-to-peer communication is all in the browser. As in, when it's downloading something, it's not downloading it from the website, it's downloading it from all of the other torrent peers and it's all in the browser. So your browser is suddenly making weird network connections to other third parties, and WebRTC is what enables all of these things. So when it comes to the newer browser technologies, we've got the ability to do things like port scans in the internal environment with some pretty heavy efficacy. So I think if we start to have more and more trouble when it comes to executing on the local file system of individual host machines, we may end up moving a substantial amount of our toolkit into the browser itself and using that browser as the agent by which we compromise other things internal to the environment and begin moving laterally. We're not quite there yet. Most of our things still kind of work on the host. You just have to find out which one's perfect. So in this case, the project here is actually a collection of several tools, because there's another problem I've kind of interacted with in our community too. So these attackers, they might be building a new backdoor for whatever the engagement is. And we can't necessarily keep up with that because there's a lot of other things involved with the backdoor. You've got to have a C2 server. You've got to have some way to push and pull the data back and forth. You have to have a UI to control that thing. And so if you're using Empire, you're probably using Empire's UI. If you're using Cobalt Strike, you're using Cobalt Strike's UI. If you're using Metasploit, you're using Metasploit multi-handlers and Meterpreter. Okay, it's another UI. If you want to build your own backdoor, you can't necessarily just build it into one of these other systems. You have to build all those other pieces as well. So these other tools that you see up here, Emergence and Oculus, are that. So Oculus is a modular C2 system that lets you set up things like handlers and HTTP listeners and such, and it sends the information to Emergence, which is an API. And so if you want to interact with that API, you want to get the information that is a callback from one of your backdoors, or if you want to create a new backdoor to interact with it, all you have to do is create a backdoor that makes the proper API calls via JSON, and suddenly your backdoor just works with the entire system, and you can use the same UI as well. So if we're in a situation where we're constantly building these new backdoors because we need to keep up with the Joneses, you have a system now where you can just make the backdoor piece much simpler than all of the other logic and such. Okay, so this is the API here. For the tool development, it's just a public API with all the API calls and objects and such. And on to the tool. So this here, the whole project, all of those different pieces, is called Prismattica. It's got its own little website, and I'm continuously developing other tools against it to be able to use all those pieces and data model. But the first piece that we're releasing here is Gryffindor and the whole C2 project there. And this is kind of what it looks like. Okay, we're almost out of time, so let's just run a couple things here. Here's an example of the backdoor. You can type something like sessions, and this can show you that there's a session now established already on the system. We can interact with that session. The session ID here, it's a little small, so hard to see. That ID is 0. It's the first session. We say interact with that session, and then we can type shell commands to have it run. We can do something like shell calc to pop a calc. We could do shell dir. It's going to run a dir on the system, and it's going to show you the files that are in that directory. Now, it's taking a little while to come back. And the reason for this is it's beaconing malware. So it's making those API calls on an interval. You can adjust that interval. Right now, the interval is 5 seconds. So every 5 seconds, it's checking in to see if there's new tasks. And then if there's no new tasks, it doesn't do anything. If there's a new task, it runs that, and it sends the information back, and the UI goes in and gets that information. This UI here is in Electron, so it will run on all operating systems, Mac OS X. Well, I say all. Electron doesn't run on mobile just yet, so no mobile. But everything else it'll run on. It's got tabs, so you can have multiple tabs as well for your multiple sessions if you want to, and all that jazz. Long term, I intend to have this UI work for other tools like Empire. Empire has a REST UI, just like the API here of the Emergence product. So you should be able to use more than one backdoor within a single system, which would be very nice to have long term. At the moment, it's just it just works for Gryffindor. All right. I think that's about all the time we have. I'll be up here for questions if you've got any, but after that I'll turn over to the new speaker. Hi, Carrie, how's it going? Speaking of, actually, you know, like that Electron UI there, I'm running one of those in Derbycon.